Hello, grade 11. So we're going to talk about the stoichiometry of gases, okay? This is a continuation of your chemistry book from chapter 2. So what's the stoichiometry of gases? So stoichiometry is the calculation that you use based on the ratio between the quantities of gas involved in a chemical reaction. We use that to predict the quantity of a reactant or product involved in a chemical reaction, in which at least one of the components is a gas. Okay, so we're gonna focus now on the gas. We can do that in any chemical reaction, but because your chapter is focused on gas, we're gonna focus on gas only. So here there is an example. We're gonna complete this table together with me. So go take your worksheet and complete together with me. Here we have this chemical reaction. So N2 together with A2 form Na3. So this chemical reaction is balanced already. So you always need to check before we start, because if it's not balanced, nothing is gonna work, okay? So here is already balanced. I have 2Na2 here, 2Na2 in the product, 6A2 here, and 6A2 in the product, okay? So first, we're gonna start with the coefficients. What are the coefficients? So coefficients are the numbers that are bigger before the element. So here, N2, how many N2 molecules of N2 do we have? 1. How many molecules of A2 do we have? 3. And how many molecules of Na3 do we have? 2. Okay, so these are the coefficients. Based on this ratio, these coefficients, we can predict the molar ratio. What's molar ratio? Is the quantity of moles that we can have in this proportional. So if you have 1 mole of Na2, how many moles of H2 do I need? 3. And how many moles of Na3 is going to be formed? 2. Okay? So we can use that to make any calculation, volume, mass, and anything. So first, volume at STP. What was the volume of STP of any gas, remember? So for any gas, 1 mole of any gas is 22.4 liters. So here I have just 1 mole of Na2, so I'm going to have 22.4 liters. But here I have 3 moles of A2, so I need to do the calculation. So 3 moles of A2, 3 times 22.4, so I have 67.2 liters of A2. What about Na3? So I have 2 moles times 22.4, so I have 44.8 liters of Na3, okay? Now let's do the same, but calculate for SATP. What's the volume of 1 mole at SATP? 24.5. So here I have 1 mole of Na2, so how many volume? 24.5. How many moles for A2 at SATP? So 3 times 24.5, so I have 73.5. And how many moles, how many liters for Na3? So I have 2 moles, 2 times 24.5, so I have 49 liters, okay? And what's the volume ratio? The same as molar ratio. So if I have 1 mole of Na2 reacting with 3 moles of A2, forming 2 moles of Na3, I'm gonna have 1 liter of Na2 react with 3 liters of A2, forming 2 liters of Na3. So for one volume, any volume, so for if this is one volume of Na2, I'm gonna have to react with 3 volumes of hydrogen. So for each liter of nitrogen, I need 3 liters of H2 to produce 2 volumes of Na3, okay, or 2 liters of Na3. Okay, so if I use 1, I need 3 of H2 to form 2 of Na3. If I need 2 liters here, it's gonna be 6 liters of H2 forming 4 liters of Na3. Okay, this is volume ratio. So this means that each time one molecule of nitrogen 2 N2 reacts with 3 molecules of hydrogen H2, 2 molecules of ammonia Na3 will be produced. Okay. Now let's do a more complex exercise. So here I have a reaction. So propane burns in the air according to the Fourier equation. What volume of oxygen is needed for the combustion of 35 liters of propane if the volumes are measured at the same conditions of temperature and pressure? So here it doesn't say if it's SATP or STP, but says all of them is in the same condition. So we don't need to worry about temperature and pressure, okay? So the first step you need to do is to look to the equation, okay? So write down again the equation with all the coefficients, okay? Now, what I need to do? First, I need to identify the ratio or the coefficients. So here, what does that mean? For 1 volume of propane, I need 5 volumes of oxygen, okay? So here it's asking me what volume of oxygen is needed for the combustion of 35 liters of propane. So I know that 1 volume of propane reacts with 5 volumes of oxygen, okay? And I also have 3 CO2 and 4 H2O. But in this case, it's not asking this, okay? So I don't need to worry about it. That's why about just propane and oxygen, that's what the exercise is asking me. So the information that it was given 35 liters of propane and I want to find the volume of oxygen, okay? So what I'm gonna do with this data? I know that the volume of the propane is 35 liters and I don't know what's the volume of oxygen. But what do I know? For 1 volume of propane, I need 5 volumes of oxygen. So if I have 1 volume, I need 5. If I have 35, how much do I need? Yes, X. I don't know, I'm going to calculate. Okay, so it's going to be proportional. So 1X is 5 times 35. So X is 175 liters. Okay, why can I do directly? Because I know the volume ratio doesn't change. So if I have 1 volume here, I have 5 here. So if I have 35 here, I'm going to have 175 here. So it's going to have 5 times more. Okay? So how do I answer my question? So the volume of oxygen needed is 175 liters. So this one was easy. I didn't have to do any conversion. Okay? Why? Because I have the volume ratio and the liters already, so I can plug in directly. Now let's do a more complex one. So the same exercise, but now what volume of carbon dioxide will be produced if 155 grams of propane react with enough oxygen at SATP? So here now I have grams, so I cannot plug in directly. But first I'm going to start with my ratio. So propane, what's the ratio? 1. Oxygen, 5. CO2, 3. In this case, I just need the CO2 and the propane because in my exercise is requesting me to do carbon dioxide and propane. That's why I'm just using the propane and the CO2. I don't need to worry about the other ones for now, okay? So what else do I have here? I know that 1 volume of propane produces 3 volumes of carbon dioxide. And I also have 5 O2 and 4 H2O. But I don't need to worry much about it for now, okay? I know 155 grams of propane and I want to know the volume of CO2. So if you pay attention here, I want to know the volume and I have grams. They are not the same unit, so you cannot plug in directly. Okay, so what I need to do? I need to use a strategy. So I need to calculate the volume of CO2, and I know the mass of propane. And I know they are a SATP. Okay, so I know that for SATP, 1 mole of any gas is 24.5 liters. So the first step I need to do, I need to calculate the mass in moles. So here I can use moles, but I cannot use mass directly because they are different. So I'm gonna convert the mass of C3H2O, the propane, to moles. So this you know how to do it. So my first step, calculation of the number of moles of propane. So here you need to calculate the molar mass. So I know you look in the periodic table. For each carbon is 12, for each hydrogen is 1. So 3 times 12 plus 8 is 44 grams per mole. So 44 grams, I know that's 1 mole. So if I have 44 grams of propane, it means it has 1 mole of propane. But here, how many grams do I have? Yes, so I have 155 grams of propane. So 155 grams propane, how many moles? Don't know yet. So the rule of 3, 44 over 155 equals to 1 over n. So 44n equals to 155. So n equals to 3.52 moles of C3H of propane. But I didn't finish yet. I just found my moles, number of moles of propane. Second step, I'm gonna calculate the number of moles of carbon dioxide. So now I know the proportion, so the ratio. If I have 1 mole of propane, I'm gonna have 3 moles of CO2. But in this case, I don't have just one, I have 3.52. So what do I need to do? Do the proportional. So 1 mole of propane to 3 moles of CO2. So 5.52 moles of C3H of propane for any moles of CO2. The same, plug in. 1 over 3.52 equals 3 times divided by n. So n equals 3 times 352. So n is equal to 10.56 moles of CO2. Okay, so now I found the number of moles of CO2. Did I finish already? No, it's not asking the moles, it's asking me the volume. Okay, so I need a third step. And I know it is SATP. So I know for 1 mole of gas, I have 24.5. So if I know the number of moles, I can calculate the volume. So my third step, now the volume of CO2. So before I calculate, so 1 mole of CO2 is 24.5 liters because it's in SATP. And I calculated before that I have 10.56 moles of CO2. And I want to know the volume of these moles. So plug in again, 1 over 10.56 equals 24.5 over volume. So my volume is going to be 10.56 times 24.5. So my volume is 2058.72 liters of CO2. Did I finish now? Yes. So what volume of carbon dioxide will be produced? So the volume of CO2 needed is 258.72. Okay? Not needed, but produced. Okay? So produced is 258.72. Okay? So take a breath, do it by yourself, okay? Watch this as many times as you need, but try to do by yourself, okay? It's really, really important to understand. And go watch again as many times as you want. Okay, so go drink some water and let's do the another one. So pause the video if you need some rest, but let's do another one now. So how many grams of H2O water will be produced by 58.2 liters of CH4 at SDP, assuming excess of HO2? So here is my equation. Okay, so I give you already balanced, so I don't need to worry about balance right now because I want you to focus on the calculation. So here, when I have methane here with oxygen, I formed carbon dioxide and water. It's a chemical reaction of combustion. So the coefficients, first step. So 1 methane, 2 waters. So here it's asking me how many grams of water. So it's asking me about water will be produced by 58.2 liters of CH4. Okay, so I'm gonna focus just in CH4 and water. So 1 volume of methane produces 2 volumes of water. And I also know 2 volumes of O2 and 1 volume of CO2, but I don't need because it's not asking me now, okay? And which information was given? So it was given 58.2 liters of CO2 and want me to calculate the grams of water, not volume, okay? Grams. And also water is liquid, so you cannot use directly the ratio because it's not gas. So I'm gonna make a list of what I have and what I need to calculate. So I have the volume CH4, so 58.2, and I need to calculate my first step, the number of moles, because from this volume I can only plug in here in moles because they are different. This is gas, this is liquid, so I cannot use directly the ratio. After that, I need to convert my H2O, my water, in also moles. So I'm gonna work with the same units. So from this volume here, 58.2, I can calculate the number of moles of CH4. And from here, I can calculate the number of moles of H2O. But the problem is not asking the number of moles, but asking the grams. So when I have the number of moles of water, I can calculate the mass of water. So we're gonna do this exercise in 3 steps, okay? So the first step, find the number of moles of CH4. How do I do that? So here, I know that SATP, okay, it was given, it's at SATP. 1 mole of any gas is 22.4 liters. So this is a gas. I can only do this for gas. I cannot do directly for water because water is liquid. So 1 mole of CH4 is 22.4 liters. And I want to calculate the number of moles that I have in 58.2 liters because it was given for me. So 1 over N is 22.4 over 58.2. So 22.4 N equals to 1 times 58.2. So N is 58.2 divided by 22.4. So the number of moles is 22.6 moles of CH4. Okay, so in 58.2 liters, I have 2.6 moles of CH2. Okay, so my first step, answer already. So how many moles do I have in 58.2 liters? 2.6 moles. Okay, now the second step, I need to calculate the number of moles of water. So find the number of moles of water. I'm going to use the ratio now, okay, because moles and moles I can compare. So from here, I know that for 1 mole of CH4, I have 2 moles of water. So 1 mole of CH4, methane, I have 2 moles of water. And how many moles of CH4 do I have? Yes, 2.6 moles. So I don't have just 1, I have 2.6. So I want to calculate how many moles of water I have. Plugging again, 1 over 2.6 equals to 2 over N. So N is 2 times 2.6. So N is equals to 5.2 moles of water. Okay, so my second step is, so I have now the number of moles of methane, the number of moles of water. But it's finished? No, because it's asking me the grams of water. So how do I calculate the grams of water? So find the number of mass of water, the grams. I need to use the molar mass. So 2 times 1 plus 16 from the periodic table equals to 18 grams per mole. Or if you know directly, okay. So I know that in 1 mole of water, I have 2 grams of water, 12 grams. Pardon, 18 grams. So 1 mole of water, 18 grams of water. And how many moles of water do I have here? 5.2. So 5.2 moles of water, and I want to calculate the mass. So 1 over 5.2 equals to 18 divided by m. So m is equals to 18 times 5.2. So m is 93.6 grams of water. Okay, the mass. Okay, so the mass of water produced is 93.6 grams. Okay, prepared for the next one? So one more. Okay, if you wanna pause, do it later, okay. So here you go. Next one. If 85 grams of Na3 decompose at 75 degrees Celsius and 2.3 atm, what volume of Na2 will be made? So I have the equation ready for you here. Okay, balanced already. So I have gas only for N2. Okay, this is important information that you observe. Okay, so all the rules for gas just apply for this. So what do I have here? First step, ratio again. Okay, so 2 of Na3 for 3 of N2. Why I'm focusing on this 2? Because I have 85 grams of Na3 and it's asking me the volume of N2. So that's what the problem is asking me. That's why I focus just on those 2. So 2 volumes of Na3 produce 3 volumes of Na2. Okay, and I also have the volume of Na, but I don't need right now. And the information that was given, 85 grams and the volume. So it's asking the volume, not the grams, so you cannot plug in directly. So be careful that they are different units, okay? So which list am I gonna do? So I know the mass of Na3 with the 85 grams, and it was given the temperature and the pressure. So leave this for now, not gonna need right now, but you're gonna need later. So what I'm gonna calculate? For me to calculate the volume of Na2, I need to know the number of moles. For me to know the number of moles of Na2, I need to know the number of moles of Na3. Okay, so my first step is to calculate the number of moles of Na3. Okay, my second step is to calculate the number of moles of Na2. And then finally, if I have the number of moles of Na2, I can calculate the volume. Okay, so let's go. First step, find the number of moles of Na3. How do I do that? I know the mass, so I need to calculate the molar mass. So for Na3, you can look in the periodic table. So it's 23 plus 3 times 14 equals to 65 grams per mole. So I know that 1 mole of Na3 is 65 grams, and for 85 grams, that what was given here, I don't know the number of moles. So 1 over n is equals to 65 over 85. So 65n is 1 times 85, and n is equals to 85 divided by 65. So n is equals to 1.31 moles of Na3. So my first information is calculated. So I know the number of moles of Na3. What do I do with that? I find the number of moles of N2. So I'm going to calculate the number of moles of Na2. So from the ratio, I know that 2 moles of Na3, I form 3 moles of Na2. But I don't have 2 moles. I have 1.31 moles that I calculated before. And I want to know the number of moles of Na2. So 2 over 1.31 equals to 3 divided by N. So 2N is 3 times 1.31. So N is 3.93 divided by 2. N is 1.96 moles of N2. Okay, so I calculate the number of moles, and I know N2 is a gas. Okay, how do I calculate the volume? The volume of a gas. In this case, it doesn't say SATP or STP, but it gives you this temperature and the pressure. And from before, we know the constant, okay? So the constant is always given to you in an exam, okay? You don't need to memorize this, but you need to remember that you need to use it. So let's calculate the volume of N2. So you need to remember, or take your worksheet to remember, how do I find the volume of a gas? Which equation can I use? Yes, so PV and NT. Remember that? So if you don't, go back to your worksheets and review it, okay? Because you need to know, you continue to know, everything is related. So, but for me to plug in here, I need to be careful with the units. For example, the temperature is in degrees Celsius, right? Can I put in degrees Celsius? No, so I need to convert to Kelvin. So 75 plus 273, 348 Kelvin. And the pressure, it was giving ATM. Can I use ATM? No. So if you don't remember, you can look in the units of the constant here. So I need to use kilopascal. How do I convert? So 1 ATM is 101.3 kilopascal. So 2.3 ATM is going to be 232.99 kilopascal. Okay? Now I can use the formula. So the pressure 232.99, the volume I don't know, I need to calculate. The number of moles I calculated before, 1.96. The constant is here, and the temperature is here. I know already. So 32.99 V. So divide. So I have 24.33 liters of N2. So, wow, so what's my answer? So the volume of N2 produced is 24.33 liters. Okay, I know it's a lot, it's a little bit complicated, but I know you are able to do it. So please watch this again and again and again and try to do by yourself, okay? I cannot control if you're gonna copy or not, so it's not up to me, but I really recommend you try to do it for you to learn. Okay, if you have any question, please text me or email me. I'm gonna be happy to help you, okay? So, have a good day and be safe, okay guys? See you. Thank you. Bye.